So hello everyone, today we'll be solving LeetCode's problem of the day. The problem statement is quite short and simple. You are given an array. You are given an array of size, something nums and an integer k. You need to return the maximum sum of a subarray of nums such that the size of the subarray is divisible by k. So the size should be divisible by k. All right. So what's the first approach that comes into your mind when someone says maximize a sum? Maximum subarray sum of size k. This is a popular problem of sliding window, right? So can we apply sliding window here? In this case, let's look at the constraints. It's 2 into 10 power 5. And we need to check the sliding window thing for. Sliding window is basically O of n approach. And so it's O of n. And we need to check for k also, right? K is 10 power 5, some 10 power 5. And length of nums of I is, okay, both are 10 power 5. So it's somewhere around, no, the sliding window won't work. But still, let's write the sliding window approach just to understand this. I've already written a few lines of code to take the input and return the function. So if you say about sliding window, the approach, first check for k size, like k size subarrays, all the k size subarrays, it's basically the brute force. You check the k size subarrays, then you check the 2k size subarrays, then you check the 3k size subarrays, 4k size subarrays, so on till while mk is less than or equal to n. Until this thing is valid, we'll check it. So if I take length less than or equal to some n and length plus equal to k, so that we always go from k, 2k, 3k, so on. And let me define n. Let me define n here. Okay, now we'll be making a sliding window here. Okay, sliding window, if you don't know the approach, the sliding window approach, it's very simple. You have a window construction pointer. So let's name it construction pointer, which starts from 0, and a window destruction pointer, which is also equal to 0. Construction pointer basically expands the window. It basically expands the window till it meets k. After k, it stops. Destruction pointer shrinks the window. Again, construction pointer constructs adds an extra element to the window. So the construction pointer, since we are doing some operation, the construction pointer would add something to the window sum. The destruction pointer would remove something from the window sum. It would destruct a particular sum. Okay, so let's consider the first k-sized window, which we can attain by construction pointer less than length, and let's take a current sum, which is equal to 0 initially, and let's take a max sum, which would be the global maximum. Max sum equal to, let's take it like negative infinity minus infinity. Let's return max sum after maximizing it completely. So current sum would be constructed the first what can I say, k-sized sub array sum would be in the current sum by the end of this loop, and we need to maximize the max sum here. Max sum equal to max of current sum comma max sum. Okay, is there any issue here? Current sum is unidentified. Did we spell it wrong somewhere here? Yeah, we did it. Yeah, okay, fine. Now, how to actually slide the window? Sliding is nothing but destructing a particular sum, destructing this particular sum and constructing a new sum. So the movement would be this. Okay, it's like, and the construction pointer should be should never exceed n. Construction pointer less than n. Current sum minus equal to nums of destruction pointer. Let's do a plus plus here. And current sum plus equal to nums of construction pointer plus plus. So the difference, since both are shifting by 1, the difference would never exceed k. The difference would never exceed k. And let's maximize this. Max sum equal to max of max sum and current sum. Okay, so this is the sliding window approach for this problem. So let's check if this works or not. It would obviously work, but I don't think it's optimal because of the constraints. So it works. I won't be submitting this because I know it's not optimal, obviously. Now let's try to optimize this. The sliding window approach is fine. Let's try to optimize this. Some things won't change, like long n equal to nums dot size. Let's keep it as it is. All right. Now, what would be the optimal approach? So if you see it carefully, if you look at the problem carefully, what's the problem all about? It's basically a range query kind of thing. It's basically a range query kind of thing where you pick a subarray of nums between L and R. You pick this particular subarray. Between L and R, and the length of the subarray, which is equal to R minus L plus 1 modulo k, should be equal to 0. The remainder should be divisible by k. Okay, perfectly divisible. So that's what the problem is all about. So can you see it's basically a range query between L and R? It's a range query. So whenever it's something related to a range query and sum with no updations, there's nothing we are updating here. We are not updating anything. So obviously we don't need a segment tree. That's what I mean. We don't need a segment tree. And however, it's a medium problem, but still we don't need a segment tree because we are not updating anything. So whenever it's about some range query and a sum, the next thing after sliding window or some 2-pointer stuff that comes into our mind is prefix sum. And constraints support it. Constraints also support it. So let's apply a prefix sum to this. So if I take a prefix sum for this, okay, n plus 1 size 0, the standard prefix sum. This should start from 1, right? The prefix sum. This should be equal to 1 and I plus plus. We note the prefix sum logic. Prefix sum of I is equal to prefix sum of I minus 1 plus nums of I minus 1. With this, we are building a prefix sum. The prefix sum, once it's successfully built, let's grab this test case. I've already taken the test case, by the way. Minus 5, 1, 2, minus 3, 4. Minus 5, 1, 2, minus 3, 4. So if I take this, minus 5, 1, 2, minus 3, and 4. The prefix sum, what's the prefix of minus 5? 0. What's the prefix of 1? Minus 5. What's the prefix of 2? Minus 5 and 1. Whose sum is minus 5 plus, basically the minus 5 plus 1, which is equal to minus 4. What's the prefix of this thing? It's minus 4 plus 2. Minus 4 plus 2, which is equal to minus 4 plus 2, which is equal to minus 2. And what's the prefix of 4? Prefix of 4 is this whole thing, which is equal to minus 5. And finally, minus 1. Okay, so this is the prefix sum we have built. We have successfully built the prefix sum. Now, if I am considering, let's say if I'm considering the sum of an mk plus r sized subarray. If I'm considering the sum of mk plus r size subarray. So if I do a modulo k here, the remainder would be r. The remainder would be r here. So to find a mk size subarray out of this, I need to remove r elements. I need to remove r elements from this. And it need not be essentially r elements. It could be any subarray. Any subarray. This is just an example where the remainder is r. I can remove any subarray whose remainder, whose remainder of size, like size modulo k is r. I can remove any subarray whose size is divisible by k, whose size is divisible by k and leaves the remainder r. I mean, whose size modulo k is r. Basically, you can remove this kind of a subarray whose size modulo k is r. You can do this so that you remove some r elements or any subarray which is causing this trouble of making an extra remainder r. You basically eliminate it. You basically prune it, eliminate it. Now I need to maximize it. One thing is clear. This particular part I need to maximize it. So I need to remove one such subarray. I need to remove such subarray which would give me a minimum sum. Which would give me a minimum sum. So what kind of subarray I should be removing? The removal condition. For a removal of subarray, I should be checking two conditions. First thing is its size modulo k should leave a remainder of r. Size modulo k should leave a remainder of r. The second condition is the sum. The sum of this subarray which I am removing should be minimum. It should be having a minimum sum. So how about, since I'm doing this, how about mapping these two? How about mapping these two? It would absolutely work. There's no problem at all in it. So instead of checking them separately, which is a bit a bit of trouble, for every remainder r, I would store the subarray which is giving the minimum sum, or for every remainder r, I would store the minimum sum. So for this, let me take a thing called vector int remainder map, or else let's call it a map, some simple map. I'm taking a map, okay, and I have to minimize it. I have to minimize the values in the map. So it would be, since I want to minimize, initially I would take all the values as infinity. And what should be the size of this map? I'm mapping the minimum sum against the remainder. The remainder would never exceed k. The remainder can hardly be 0, 1, 2, so on till k minus 1. So if I take this map of size, k, it would be absolutely fine. Now I need to iterate over my prefix sum. And yeah, one more thing which is in my mind is that map of 0 is always 0. Let me explain this. This is very interesting. I can take an empty subarray of size 0 whose modulo k is also 0. 0 modulo k is also 0. So I can say that map of the one leaving the remainder 0. What's the sum of elements in it? There are so many elements, right? We cannot actually sum them up. There are so many elements. Yeah, there are so many elements, right? Just by looking, we can say that this has no elements and its sum is 0. So let's iterate over the prefix sum. We don't need to check for this. I less than n and I plus plus. Okay, we are iterating over prefix sum, so it should be I less than or equal to n. And let's take the remainder. Okay, so if you are doing prefix sum, if I is somewhere here where the value of I is some mk plus r, that means you're taking a subarray from 0 to mk plus r, right? You're taking the subarray from 0 to mk plus r. Again, mk plus r is a this plus r is a standard example which I'm considering, it need not be R. It's basically a reminder. It's basically a reminder. So you're taking some reminder. You're taking a subarray whose reminder is R. So let's take that reminder R equal to I modulo K. R equal to I modulo K. And I need to remove these R elements from it. I need to remove these R elements from it, or any subarray whose reminder is R. So so to do that, I need to take, okay, let's keep it int only, no problem. Min sum, where am I storing the minimum sum? Where am I storing the minimum subarray sum whose reminder is R? I'm storing it in map of R. Alright, I'm storing it in map of R. This should be long, I guess. I'm storing it in map of R. Now, I need to, okay, let's think of it like I need to take an answer. Since I want to maximize the answer, let's take it minus infinity and return answer. Okay, I need to maximize it. So answer equal to max of answer comma, and what's the possible answer? I need to remove this R elements. So from prefix sum of I, I need to remove this min sum. All right, I need to remove this min sum. And if I find something more minimum, I need to update the map of R equal to minimum of the current min sum which I'm storing inside the map, and the sum which I computed just now. Prefix sum of I minus min sum. All right, this is what I should be doing. And one thing is clear, you won't be doing this when min sum. You would be doing this only when it's not equal to L on max. Okay. So let's try running this, and it failed. It's printing some huge value. Answer equal to L long min. So it's not a negative value. That means it's something related to the L long max itself. So you're maximizing this. Wait, let's debug it. Let's debug it. Logic is absolutely right. No need to worry. So you made a prefix sum, built a prefix sum. Map is, we are minimizing the values inside the map, so we took it along max, which is absolutely fine. And map of 0 is equal to 0. Let's remove this if statement. It's still printing this only. Maximizing the answer, minimizing the map value. Answer, since we are maximizing the answer, took it as negative infinity. Since we are uh, minimizing the map value, took it as positive infinity. What could possibly go wrong? Uh, so there are only two values here for auto and %a in map. So it's still printing that infinity thing, but the expected output is 4. Let's try running this in LeetCode once. Okay. Runtime error, integer overflow. But we are taking long. What could be the reason for this? I guess I need to debug everything. The logic is absolutely fine. Let's debug the prefix sum first. What exactly is prefix sum storing? So it's fine, it's the same. Prefix sum has no issues. Now let's debug this map. I equal to 0, I less than k, I plus plus. C out I. Okay, so this thing. What exactly is map storing? At this point, it's storing 0. We made a map of size 2, right? Yeah, then it's fine. It's storing this thing. If I do the same thing here, the first one should become 0. First one is 0, second one is long max. Answer equal to long min. Okay, so now it's time to actually debug answer in every iteration. Like what is it actually becoming? So initially answer equal to -4, -4, -1. And lastly, it's becoming, in the last iteration only, it's becoming that thing. So there's some okay, so this is prefix sum of I minus min sum equal to map of R. So let's see where are we getting this error. And let's print this one also, prefix sum of I minus min sum. Okay, so um, first thing we are printing is prefix sum, which is fine, which looks fine. Map before keeping map of 0 equal to 0. Map after keeping map of 0 is equal to 0. And what else are we printing? Let's have a endl after this. Okay, what else are we printing here? We are printing answers value. Answer is initially -4. Prefix sum of I minus min sum is also equal to -4. And then it somehow becomes this. So when would it have become -4 and other stuff? Hmm. Okay, so one thing is clear. This should be equal to prefix sum, because prefix sum is giving us the value of that I modulo k. Okay. So what was the error exactly? Let me tell you. What did we do? The mistake. We wrote this particular statement wrong. Prefix sum of I minus min sum. Prefix sum of I minus min sum would always give you this particular thing. But map of ours should store the minimum sum with this particular reminder. It should store the minimum sum with this particular reminder, which we missed to write. I uh, I accidentally wrote it actually. This thing was only in my mind. Happens sometimes. So let's um, try submitting this. Let's edit in actual LeetCode also. It should get accepted. Yeah. And it beats this. Okay, not bad. But can we optimize it further? Can we optimize it further? Let's remove this debug statements. Okay, so let's remove this debug statements wherever they are. Fine. Can we optimize this further? Can we optimize this further? I feel yes, we can optimize this further. So here we are building a prefix sum array. Here we are building a prefix sum array. Is that necessary? Because every time you are taking prefix sum from 0 to L, 0 to some R only, 0 to some, or 0 to some I only. So how about whenever some L is fixed, you never use this prefix sum if you want the solution to be optimal. Instead, we have something called as a running prefix sum. We have something called as a running prefix sum. Running prefix sum is very simple. Running prefix sum is just basically taking initially a prefix equal to 0. And since you're fixing some L always, you need not worry about that L. In our case, L is 0, so we not at all consider 0 in this case. Nums of I. Let's add nums of I to this. Alright, so it's not prefix sum, it's prefix. Okay, so this would make a running prefix sum. Wherever you are writing prefix sum of I, you can just replace it with prefix, the running prefix sum. Okay, and we need not declare this arrow also. Alright, so let's try running this, and it failed. Why did it fail now? It's just running prefix sum, right? It's just running prefix sum. Where does it fail? Okay, let's LeetCode has a better debugging than the compilation errors given by the compiler. Now let's try running this. Prefix sum plus equal to nums of I. What's wrong in this? Yeah, done. Let's do the same change here. We were taking less than or equal to. We forgot to change the for loop. Yeah, it is giving the wrong answer. Okay, it still fails some test cases. So once again, why running prefix sum is not working? I guess because prefix equal to 0, this is nowhere happening. It's not happening anywhere. So that's why this is not working. So let's try this once again. Let's try thinking of fixing this. Writing this from scratch would be a little easier. Writing this from scratch would be a little easier, but let's try to fix this itself. Okay, so there's this one thing which we need to consider, that is now prefix sum, we don't have n plus 1 size. Prefix sum doesn't have n plus 1 size anymore. Like it's getting started from 0. So it basically means you need to add a plus 1 here to adjust it. This was an off by 1 error. If you run this again, this will get accepted and hopefully get submitted also. Yeah. Okay, so that's it guys for today. The problem of the day was quite interesting. The debugging was also a key takeaway from this problem. I usually never post the debugging thing in YouTube, but yeah. So thank you everyone.